Hello, welcome to the playlist on digital communication systems. In the lecture 2, we will study about the block diagram of digital communication system. So the main purpose of the digital communication system is to transmit the message or the symbols from source to the destination. So the first block in the basic model of the digital communication system is source. So when we try to understand about the source, nothing but information source. It may be analog or it may be discrete. Analog or discrete. The various forms of the message signal may be, it may be of the audio form, image or video signal, and sometimes it may be non-electrical signal even. So when the signal is a non-electrical signal, we need to convert it into electrical signal. Here we use transducer to convert the non-electrical signal into electrical signal. So the output of the source may be analog or discrete. And here in the source we may also have a transducer also in order to convert a non-electrical signal to electrical signal. The next block in the basic model is source encoder. So then input signal, the input signal coming to the source encoder is analog or discrete signal. The symbols which are produced by the information source are given to the source encoder, and these symbols, these cannot be transmitted directly, so they are to be converted to digital form, nothing but the binary sequence of zeros and ones. So what does the source encoder does for us? The first thing, it converts the input. Input is nothing but the symbols or the output of information source is converted to binary sequences. Binary sequences, nothing but zeros and ones. And here the source encoder reduces the redundancy. Reduces redundancy of the message signal. Thus, reducing the redundancy reduces the bandwidth requirement. And the popular coding techniques use it for reducing the redundancy or used as the source encoding are Huffman coding, or Shannon-Fano coding. So what is the function of the source encoder? It converts the output of the information source into binary sequences. It reduces the redundancy, thus reducing the bandwidth requirement, and the coding techniques used here are Huffman coding and Shannon-Fano coding. The next block is channel encoder. So now after converting the message or the information signal into the binary sequence by the source encoder, now the signal is transmitted through the channel. So for example, the form of the signal here is analog or discrete, and here it is digital. Now this has to be transmitted through the channel, and we all know that the channel adds the noise. The channel adds noise as well as interference. So therefore, when the channel adds the noise and interference, what happens? The errors get introduced. Errors get introduced into the binary stream. Binary stream or the binary sequence. So in order to avoid this, we go with the channel encoding. So I'll repeat it once again. The source encoder, the output of the source encoder is nothing but the binary sequence of zeros and ones. And now this has to be transmitted through the channel. The channel introduces the noise and interference. Thus the errors get introduced into the message bits. To avoid that, or to detect and correct these errors, completely we cannot avoid it. So in order to detect the errors and correct those errors, we use the channel coding. Now how do this channel coding works? This channel coding adds redundancy bits, means extra bits are added. So these, for example, message bits plus some redundancy bits. So thus forms the here the word which has to be transmitted. Now the next block is modulator. So what is a modulator? So actually the modulation process is nothing but we say it as frequency translation, which you have already learnt in the signals and systems, frequency translation. Or we can also say it as if the modulating signal is digital. If the modulating signal is digital, then we are going to superimpose it on a high frequency sinusoidal signal. For example, if I have a bit stream like this, 1 0 1 0 1, and we are transmitting one bit at a time using the digital modulator. So here we are going to superimpose the 1 on the frequency, for example S2 of t, and 0 on another frequency S1 of t, and then again 1 on the S2 of t, again 0 on the S2 of t. So if you see, the signal S1 of t has a lower frequency compared to the S2 of t. So this means that the signal carrier is converted into two waveforms. Now what are the two waveforms? S1 of t and S2 of t. And this is done by the digital modulation. So the output of the modulator is given to the antenna. So what does the transmitter antenna does? It converts this waveform into electromagnetic waves, EM waves, and after converting it is given to the channel. So this communication, it may be, this channel may be wireless or using the wire lines or using fiber optic cables. So after completing the various blocks at the transmitter side are, first we have the information source, and then source encoder, channel encoder, and then we have the modulator, antenna, and the signal is transmitted into the through the channel. Now at the receiving end, we have receiver antenna. So the receiver antenna converts the, so the inputs are your EM waves. EM waves are converted again back to the modulated signal. Modulated signal. So depending upon the modulation technique we have used, we will get the modulated signal. The modulated signal is given to the demodulator. So what does the demodulator does? Here we extract the message signal. So whatever we have transmitted, we extract the message signal from the modulated signal. And after we get the modulated signal, then it is passed through the channel decoder. So channel decoder, here we check for errors, and if there are any errors, the correction also is done. Check for errors and correcting the errors is also done at the channel decoder. And whatever the extra bits we have added, we remove it here. So removes the redundancy. And then it is given to the source decoder. So what the source decoder does? First it converts digital signal. It converts the digital signal into analog or discrete form. And then the signal is given to the destination, or here we can also say it as this as an output transducer. So here we may get the audio, whatever we have transmitted, audio, video or text, anything like whatever we have transmitted, we try to get over at the receiver destination end. So this is about the block diagram of digital communication system. Thank you for watching. My next lecture would be on the sampling theorem. Thank you all.